Hi, this is Meet. So today we are gonna look at a very nice project which is IPL match win predictor. Now we almost everyone in India is fond of IPL, right? So why not try to do some data science project on IPL? Okay. So what is this project all about? So this project is all about predicting the probability of the team winning, basically. So, as the tagline goes, based on the first inning performance of a team, this app takes in current data of second innings and tries to predict the win probability of either of the teams. For example, Chennai Super Kings and Mumbai Indians are playing. Chennai Super Kings batted first and they gave a target of 180 runs to Mumbai Indians. Now, over by over, we will try to predict what is the win percentage of Mumbai Indians and win percentage of Chennai Super Kings. Okay, so this will be more clear when we will try to look at the uh, project, like the live demo of the project. Before that, let's look at the flow, how the flow goes. We will load the data set into pandas data frames. We would perform exploratory data analysis, normal routine of data science project. Then we will fit a machine learning pipeline to the extracted features in data. Again, a normal step in the machine learning process, and then we will integrate that machine learning pipeline with the UI, which we will make it using Streamlit, or we can also make it using Flask, and then we will deploy the model, right? So let's look at the working demo of this. So the demo is over here. Let's say that the team is Kolkata Knight Riders, who is batting. So second innings is happening and Kolkata Knight Riders is batting and Chennai Super Kings is bowling, and the match is played at Kolkata. You can also select whatever location you want. I preferably select Kolkata, hometown. Then the target given to Kolkata Knight Riders is 180. Let's say that the score currently of Kolkata is 100 runs and the overs completed are, let's say 10 overs are completed, and let's say 4 wickets have fallen, right? So based on this current situation, like 10 overs are completed, that the 11th over is running, score of Kolkata Knight Riders is 100 runs for 4 wickets and the target is 180. Let's see the probability. Yeah, so here we can see the probability of Kolkata Knight Riders winning is 64% and Chennai Super Kings winning is 36%. Kind of it is appropriate only, because in 10 why the first 10 overs are completed, so there are more 10 overs. That means we are having 60 balls and 80 runs, right? And the batsmen are 4 down and 5 down batsmen, so they are almost like all-rounders, so they can manage the score. Okay, let's see a situation where I give for example the overs completed are 10 and let's say no wickets are fallen. Let's see the probability. Yeah, so opening batsmen are almost, they are always good, so the probability of Kolkata winning is 96. Now let's say that overs completed are 10 and wickets fallen are 7 wickets are fallen down. Let's see what is the probability now. See, Chennai Super Kings have a higher edge now, like 79% Chennai Super Kings can win because 7 wickets are already fallen. And why 21% to Kolkata? Because of this overs, I think. 10 overs are completed, right? More 10 overs are there. So, and 100 is the score. 80 runs, 60 balls. 7 wickets have fallen. 79%. A decent prediction is being made. Not even totally biased over Chennai completely, like 98% Chennai will only win and 2% only there is a hope for Kolkata. No. Anything can happen. So that is why a decent amount of probability has been assumed here. So yeah, this is all about the project. So at every stage we can just look up and we can try and see what would be the kind of fluctuation and everything according to the over, what the stats is all about. So this is all about the introduction. So we will look at the implementation of this from the next video onwards. Thank you. Hi, In the last video, we saw the working demo of our IPL win predictor, where we saw that where we gave some various kinds of inputs in score, wickets fallen, and overs completed, and also the target. And we saw that our model is kind of predicting good as compared to other things. So let's try to code it up. So here I'll be using two CSV files. One is matches.csv and one is deliveries.csv. So these files I'll be providing them in the code files, so please do check it. So here first we'll load all the dependencies as usual. The start of machine learning project, we would require pandas for panel data, numpy for numeric operations, seaborn and matplotlib for visualizations. Great. After doing this, we would load our CSV files into data frames. So matches.head and matches deliveries. So matches, the shape of matches is 756, whereas deliveries is 1,80,000 almost. So basically delivery is like ball by ball, and the data set which we are having, the data set is from 2009 to 2018. So the IPL season, which it started from 2008, maybe 2008, right? So from 2008 to 2019, the data set is ball by ball record. So that is why the delivery shape is too much, and our main focus will be in extracting this delivery shape only. So what we will be aiming for, what all features we will be aiming for, first let me show you those features. So the features which we will be aiming for are the batting team, the bowling team, the city or the venue where the match is being played, the number of runs which are left, the number of balls which are left, wickets, total runs, current run rate, required run rate, and result. So these are the fields which we will be looking for, right? So as we have seen the shape, let's see the head part of it. There are 21 columns in deliveries and 5 rows. So let's see what are all the columns which we are having. We are having match ID, inning, batting team, bowling team, over, ball, and all. Right. So in the project overview, I said that the first innings, we are assuming that the team has already batted. Okay. The team has already batted for the first innings. Now second innings is going to happen, and we want to see which team is winning. So over here what is happening is, second innings batting team is getting predicted, and second innings bowling team, that is nothing but the team which has batted in the first innings, is getting predicted here. Okay. So what we will do is, we will group the first innings, second innings score in a particular match ID. Let's say match ID is equals to 1. So inning 1 score is 207, inning 2 score is 172, in that way. So what do I mean by this is, in deliveries column, if I paste this, okay, just see what happens. I am saying deliveries.group by, I am grouping my data with respect to match ID and inning, and I am summing it with respect to what? With respect to the total runs. So if I see the total runs over here, these runs are ball by ball. Okay, one ball run is 0, second ball run is 0, like that. Ball by ball the runs are. I want to sum those runs according to inning wise. Okay, and every match has a particular match ID, and every match will have 2 innings, either first innings, second innings, and if there is any kind of draw or duck with Lewis method is applied, we will ignore it in the future thing. But for now, we are considering that every match has a particular match ID, and every match is having 2 innings, first innings and second innings. So what we are doing is, we are summing the total runs, which is nothing but ball by ball runs, into inning wise. So when I show this, it will be more clear. So here, as you can see, match ID is 1. First innings, the particular team who batted, they scored 207 runs. Okay, and first match ID, second innings, the team which batted or the team which chased 207 was about to chase 207. They were all out in 172 runs. So basically, match ID 1, the team who batted first won the game. Okay. Similarly, match ID 2, that is nothing but second match. In second match, the first inning score was 184 and second inning score was 187. That is, the team who was chasing that 184 runs, they won the game. Right. So in this way, I am trying to get my data. Okay. So this is what is the thing. And when I do this reset index will convert the series into a data frame. Okay. This reset index will convert this series into a data frame. Just a minute, it will showcase. It will convert the series into data frame. As you can see here, it converted the series into data frame. Match ID 1, first innings runs are 207, match ID 1, second innings run is 172, like that. Okay, so the same thing I am storing into train DF. Okay, so the same thing I am storing into train DF. Yes, so the same thing I'm storing into this. Now what is happening is, now I'm considering only the first inning score, capturing the first innings, as we will be predicting from the second innings, right? So what I'll do, I'll capture the first inning score only first. So total runs is equals to total run DF of inning, wherever it is 1, I'm capturing that. And now what will happen is, the target always will be the total runs scored plus 1, right? So let's say that the team A in the first innings they scored 207 runs. So the target for team B will be 208 runs. So that is why total run DF of total runs dot apply lambda x plus 1. This function you must have been very familiar. I use this a lot of times. This basically is an inline for loop which says that for every run in this total run, you add extra 1 to this. That is it. That is nothing but this lambda function. What it's doing is this only. So if I try to execute this, I'll be getting the result here. So 207 became 208, 185. Now I lost all those second innings because I'm considering only about the first innings. So once if I get this, I'll find the columns and then I will merge the data now. So I'm getting this total run DF. I calculated this. Now we'll try to merge it. Now with what I'll merge with matches. Okay. So merging the total first inning score DF with matches DF with left side on ID and right side on match ID. So over here, what is the thing? Match ID is over here. And in matches, what is the thing? Match ID is there. Okay. In deliveries, match ID is there, whereas in matches, ID is there. So I'm gonna merge this. I'm gonna merge my total run data frame with matches. So in matches, what I'm having ID. So in matches, ID is the thing. So ID of matches data frame and match ID of total run data frame are same only. So I'm gonna merge them. So what is the syntax for merging is matches.merge total run of match ID total runs. I do not want innings because I know that innings is 1 only. So it is useless to keep this. Okay. So match ID and total runs are important for me. So I am selecting match ID and total runs, and left on is equals to ID and right on is match ID. So left on is meaning what means see, so what we want is we want to merge matches. We want to merge what matches, and we want to merge matches and run DF, right? We want to match matches and run DF. So in matches, which column is similar to run DF? ID column. So if we try to write the SQL code, what it will be, if we try to join, select some from matches, inner join, left join on match.id is equals to run df run df dot match id. We do this, right? Run df dot match id. So this is the right join. I mean, this is the right side column on which we are joining, and this is the left side column on which we are joining. So in pandas, the syntax is this. So left on is id. That means matches column has id column. We are joining on it, and right on is match id. Match id is nothing but this, which is nothing but total run df. So both are similar, so we are merging them. So this is all about the merge function, and when we execute this, we will get the merged data frame where we will have this total runs, match id, everything. Okay, so if we see, we get this total runs and match id. Now we will see the unique columns. Now we'll see the unique teams. So we have some too many unique teams, but we will consider the teams which are frequently participating in our IPL. The most frequently occurring teams only we will consider on all seasons of IPL. So I have shortlisted some teams. Then this Delhi Daredevils is newly termed as Delhi Capitals now. So previously it was Delhi Daredevils only. So I'll be replacing it. I'll be replacing the name of Delhi. I'll be replacing the name of like Delhi Daredevils with Delhi Capitals, because Delhi Capitals is the current name. Similarly for Deccan Chargers also, I'll replace it with Sunrisers Hyderabad, because Sunrisers Hyderabad is the new term, and it new team name, and it should be carried forward. So I'll execute this. So once this is executed, I will say consider only those teams which are there in these teams. This is nothing but that. Okay, match df of team dot is in teams. This will return a boolean thing which says that okay, I am considering only the teams which are present in this. Okay, and similarly with team 2, team 1 and team 2 will be there in a match. Team 1 is for batting or bowling, and team 2 also for batting and bowling. So match df of team 1 unique. So we get this, and then we'll see the shape. It's 641, and then we'll see the head. That's all for this one. In the next video, we'll carry on with exploring more of these features. Hi. So in the last video, we saw there are few replacements which needs to be done. Like the Delhi Daredevils, whichever it is present, we need to replace it with Delhi Capitals. And same goes with Deccan Chargers. We need to replace it with Sunrisers Hyderabad. And then we saw how we merge the matches df and run matches data frame, and then the total run data frame. So we got the data frame after all like this. Now we will move ahead with our exploratory data analysis part. So over here we will check with the matches which resulted in DL method. DL is nothing but the duct with Lewis method. DL applied. Basically this happens when there is some kind of rain, or because of some kind of situation the match has got abandoned, and then with the help of DL method they will say this team 1 and that team 1 and so on. So let's try to figure it out, which teams are there, which matches got affected by that. So I would say match df of DL applied is equals to 1. Wherever there is DL applied, inside this data frame you applied a particular style with the background gradient as plasma. This is the meaning. Simple as that. I'll repeat it. Whichever matches had undergone DL method, inside the data frame known as match df, to all those matches you apply a particular style which must have a background as plasma. Okay, so when I shift enter this, I will get a particular data frame which will showcase me this all df applied matches 1 1 1 1 1 1 1 1 1. Okay, so 2017, 2008, 2009, 2011, and these all matches, they were DL methods. So we will exclude this DL method. Okay, so ignoring the rows which are with the DL method, we are considering only the matches which are completely played. First innings and second innings, they are played completely. So match df is equals to match df of DL applied double equals to 0. Instead of 1, I am keeping 0. That means this will give me all the records which are all the records of matches which are completely played. And then from this match df, what I'm bothered about is the match ID, the city, the winner, and the total runs. I don't want anything else. I don't want this toss decision, win by runs, win by wickets, venue, umpire 1, umpire 2, umpire 3. I don't want all that. I only want match ID, city, winner, total runs. If I execute this, see, I got the result as match ID, cities, winner, total runs. Once I get this, what I will see, now this match DF is completely pre-processed. Now the major part which we are looking from where we will extract the more important features are from the deliveries data frame. So let's see the deliveries.head data frame first. So when we say deliveries.head, we will get the head, we will get the first 3 records of the deliveries data frame. Now there is a catch here. See, in the match data frame we are having match ID, right? And in the deliveries also we are having match ID. So if we merge this match data frame with this deliveries data frame into a single data frame, we can perform lot of operations on it, right? Instead of performing separate operations on match data frame and separate operations on deliveries data frame and then combining, what I am doing is I am combining those data frames together into a single data frame, and then I'll apply all the operations on that data frame only. That makes the task little bit easier. So for doing that, what I will do, I will merge the data frames. So match DF I want to merge with deliveries DF. So what is the common column in match DF and deliveries DF? Match ID is column. Match ID is common in deliveries data frame as well as match data frame. So match data frame dot merge on which data frame do you want to merge? You want to merge with deliveries. On which column do you want to merge? On match ID. Why match ID? Because match ID is common in both deliveries data frame and match data frame, right? So this everything I'm storing as the result of this merge data frame, I'm storing in this delivery data frame. So here I'm having 21 columns. No, now I will have 24 columns because 3 columns of this are getting added to this, right? Don't consider this match ID again, because match ID, on that only we are joining. So that is included already in this deliveries. City, winner and total runs are the 3 additional columns which will come. So I'm storing the result into match delivery. Let's see what happens. So I get 24 columns now. Okay. So match ID, city, winner, total runs X. Now over here we are having total runs. No, here also we are having total runs. In deliveries data frame also we had total runs. So in 2 places we are having total runs, right? So the total runs of match DF will be considered to be total runs X, and total runs of deliveries data frame will be considered as total runs Y. Why it will be considered like this? Because what we are trying to do is we are trying to merge the match data frame with deliveries data frame. So whatever data frame is on which we are merging, that will be considered as Y. Okay, so that will be considered as Y. So Y is what over here we want to, so basically what is happening, X merges with Y. So this is the thing. So every column in X data frame will have a underscore X representation. Similar columns will have underscore X representations, and similar columns in Y which are present in X will have a representation of underscore Y. So here what will happen is we'll be having total runs X. Why total runs X? Because in match DF also we are having total runs, and in deliveries also we'll be having total runs. So if you see here, there will be one total runs Y also. Okay, so yeah, so if you see, we will be having a total runs Y also over here, as you can see here, total runs Y. Okay, and here we are having total runs X. So I'll merge this. So this is done, and then I will see the columns. So what all columns are there? So I'm having this total runs X column and total runs Y column, right? Both X and Y runs are there now. Got it? Now what I will do? Now I will consider only the second innings. From now onwards, I'll consider only second innings, and that we will see in the next video. That is little bit tricky. So till then, do practice a lot on merging, because merging will help a lot. Thank you. Hey, so in the last video we saw how this merging thing happens, and it played a very important role in merging 2 data frames, important data frames, that is this match DF and the deliveries data frame. Now what we will do is we will proceed with the further stages. So if you just if you have a look over here, over here in the match data frame, what we were having is we were having city, winner and total runs, right? So 3 additional columns came into picture, and this match ID we were merging it, so that will obviously be counted as one column only, because that column is common in both match data frame as well as in deliveries data frame. So these 3 columns were new, and these 3 columns we were able to see over here. As total runs was here as well as in the deliveries. So the total runs got replaced with total runs X and then total runs Y respectively. Okay, total runs Y indicate that this total runs Y indicate that these total runs were from deliveries data frame, and then this total runs X indicate that this total runs were from the match DF data frame. And the naming convention I explained in the last video. So now what will happen is, now we know that previously we considered only first innings, right? If we go back, we considered only first innings over here. Inning is equals to 1. So what does this conclude is, this match data frame is there now, which we made a lot, So this match data frame is already a data frame of first innings. So this all rows, this all runs, they are the scores of first innings only. So this batsman underscore X is there now, total runs X. So these are the scores of first innings only. Now what we need to do is we need to consider second innings, because we are trying to predict the probability of winning or losing for the second innings, right? So what we will be doing, this is a very important step. If you miss this step, that means the entire flow of the project goes. Okay, so we will be considering delivery DF of innings is equals to 2. That means from this delivery data frame, whichever row is having second innings, you consider that. Okay, so we are considering second innings from this delivery data frame. This will make a major change, entire change. Okay, this is the most important step. If you don't do this step, this will ruin everything, because I'll say this total runs X is there. This is already computed previously. Where it was computed? It was computed where? It was computed here at cell number 10. It was computed DF equals to 1, and this total run DF was converted to match DF, and this match DF later on was merged with deliveries DF. Why it was merged? So that all the competitions can be done easily. Okay, so now we are not, so this total runs X is there. So this total runs X gives us the first inning score, complete score of first innings. But if we look at total runs Y, we are having ball by ball score of second innings, not complete score. We are having ball by ball score. For example, first ball runs scored were 0, second ball runs scored were 0, like that. Okay, that is why this delivery data frame is so large and that match DF data frame is less. Got it? So that is the reason we have to select the inning to be 2. Now we select the inning to be 2. Now if we look at the shape of the delivery data frame, as we have skipped the first innings from the delivery data frame, because that first inning score we have computed in the match data frame and then we joined it. So we are already having the first inning score. Now we want to consider only second inning score. That's why we did DF. That's why we did this step. After doing that step, we saw that the number of rows were decreased. So now whatever I said is written over here. You can just read this and you can get the idea of it. Now what we will do is we will count the current score of a particular match. So what we will do is we will copy this. So for better understanding, we will do this. Okay, so now we'll go step by step in this. So first we will not consider this total runs Y. Okay, first we will not consider the total runs Y. First we will say we will consider this only. So what we will be having is, if I group all the match IDs with their cumulative sums, So I will get this total runs here. Okay. So with respect to what I should accumulate it is basically this one. So what does this mean is 125 match. Okay. Total runs y in 125th match ID where this much, 126 where this much, 129 where this much. So this is basically ball by ball sum, right? This is basically what? Ball by ball sum, right? So I want the current score in that particular thing. I want what? I want the particular score. I want the current score of that particular thing. So I'm doing delivery df dot group by. I'm grouping with that match dot cumulative sum of total runs y. If I do this, I'll get the current score. So current score is 111337 and all. Okay. Now I'll consider the runs which are left. So what does this mean is this current score is basically the ball by ball score. Okay. So how many runs are left? That is also a good feature which we need to extract. So runs left will be total runs x minus current score. See, so total runs x means what? We need to find the this is the target which has been given by the team A. Now we are batting as team B and our current score is, let's say, 1. Let's say our current score now is 1. So how many runs will be left to chase? So 207 runs are left to chase, right? So this is what this entire thing is doing. So delivery df of runs left is equals to delivery df of total runs x minus delivery df of current score. If we execute it, we get this result. Runs left are 207, 207, 205 and all. So basically what this means, you know, what this current score is and everything is, I'll say you. For example, let me just make this more clear. Okay. For example, there are 6 balls. Yeah, we all know that there are 6 balls in 1 over. Okay. In 1 over. Let's say that for the first run, for the first ball, the batsman scored 1 run. Okay. And then there were 2 dots. And then there were dots from ball number 2 and ball number 3. So ball number 2, ball number 3 runs made were how many? 0 runs. But total runs were made how many? 1 run, right? What this indicates? There are 3 balls. In 3 balls, in the first ball there was 1 run made. In the first ball there was one run made, and in the next 2 balls the ball was dot ball. So second ball was dot, third ball was dot. There were no runs made on those 2 balls. But the total score in those 3 balls is what? 1. So that is the meaning of cumulative sum. Okay. And let's say that in the 4th ball, let's say that over here you can see, let's the first ball the run was 1. Okay. The second 2 balls were dot. That means there were no runs scored. But on the 4th ball, there was 2 runs scored. So total score became now 3. Right, and then there was a 4, so the total runs became 7. So after the 5th ball the total score was 7. That means 0.5 overs score is 7. This is the logic which we did over here. Okay, so grouping the runs, grouping the matches with the help of match ID, and then we will finding cumulative sum. As I explained now what cumulative sum is with respect to a particular over. Let's say that particular over, first ball, the batsman took a single. So the total score of the team is 1. Then in the next 2 balls, there were no runs which are scored by the batsman. So the team score is 1 and the balls played are 3. Next, on the 4th ball, the batsman took 2 runs. So the team score became 3 and the balls became 4. And on the 5th ball, the batsman hit a 4. So the runs became 7 and balls became 5. And in the 6th ball, there were no run taken. It was a dot ball. So after the end of the first over, the score became 7. So that is what this cumulative sum does. Okay, I hope that makes sense. If not, please do rewind and look and try to explore yourself. You'll get understanding of it. Then we are calculating the total runs left simultaneously. Okay, so total runs left, we are calculating it simultaneously. If we see, we get this. Now this is important. Now we will, as we are calculating the total runs left, we will calculate the total balls left as well. So we know that this is IPL is all about 20-20 cricket. So 20 into 6 is 120. So there are 120 balls. So if one ball is played, that means 119 balls are left. 2 balls are played, 118 balls are left. In the same manner, instead of doing this, I will do 126 minus overtime 6 plus current ball. This also makes the same thing only, right? See, over is remaining same. For example, in a particular over, ball by ball the record is there, right? So first ball, first over, first ball, first over, second ball, first over, third ball, first over, fourth ball, first over, fifth ball, first over, sixth ball. You're getting the thing. One is repeating 6 times. It is staying as it is. Only the current ball is changing, like 1, 2, 3, 4, 5, 6, but over is remaining the same. So that's what I'm doing. This over star 6 plus current ball, and totally I'm subtracting it from 126. This logic also gives the same answer as this one. Okay, so the same thing I have applied over here. 126 minus delivery df of over times 6. Delivery df of over is what? This over, right? The see the change here. This is what I was talking about. Over 1, ball number 1, over 1, ball number 2, over 1, ball number 3, over 1, ball number 4, over 1, ball number 5, like that. Okay, so if you do this, we will be getting the balls left. So what are all the balls left? We'll be seeing here. Okay, so 150, 119, 18, 17, this will keep on decreasing. Now we will calculate the dismissal players in the next video. Till then, do for sure do practice this line and do understand this line, because this line and this line changes the entire scenario for project. Hi, so in the last video we covered the logic of cumulative sum, and then we calculated the runs left and the overs left. Balls left. So now in this video we will see the dismissal, player dismissal or the wickets dismissal, whether on a particular ball whether the player was dismissed or the player had survived. Okay, so we'll see that. So we will just try to first look at the unique values of player dismissed. We see that there are names over here, right? So there are names. So we do not want names over here. We want either in a boolean form, like whether the player was there or the player got dismissed. So for that, what we will do is, if the player was not dismissed, then there was NaN over there. So if we just have a look over here, player dismissed, NaN means player was batting at the crease, he was not dismissed, he was playing. NaN means player was not dismissed, he was playing. Now over here, wherever there is SR, Watson, or if there is any name, that means the player was out. So you can see the type of dismissal also, like the player SR Watson was run out by Kunal Pandya. So like that. Okay, so we will try to find out the we will try to replace this NaN first. Okay, this NaN we will try to replace it with 0. That means the player was not dismissed. And if the player is dismissed, if there is some kind of name, that means we will replace it with 1. So whenever there is 1, that means the player has been dismissed. Whenever there is no 1, that means whenever there is 0, the player was not dismissed. So the same thing will apply over here. So we are saying filling in NaN values with 0, player dismissed is equals to delivery dismissed dot fill NA as 0. Now we will convert this player dismissed column into a boolean column. If the player is not dismissed, then it's 0, else it's 1. So delivery df is equals to delivery df of player dismissed is equals to delivery df of player dismissed dot apply. As I covered so many times, that this lambda is nothing but an inline for loop. It says that for every element in this player dismissed, if that element is 0, then keep it, then say 0, else keep it as 1. Okay, so now as these are strings over here, now we need to convert it into integers. So that's why we are using this as type of int, and then we will see the unique features. Now if you see the unique features, we have successfully converted the player dismissed from this big chunk. So from this big chunk to a small boolean list, that is 0 and 1, where 0 indicates that the player was not dismissed on that current delivery and 1 indicates that the player was dismissed. Okay, now wickets fallen. So we will see how many this thing was happening over here. Okay, so we will copy this. For better understanding, we will copy this first and we will see separately what it is happening, and then we will assign these things. Okay, so we will see this, what this thing is saying all about. So delivery df.group by match id, I am grouping with match id, and then I am calculating the cumulative sum of player dismissed. This similar kind of cumulative sum was calculated where? It was calculated over here. Okay, so what this is saying is, see, this is what this is saying is very simple over here. So first, if you try to look at the shape of this is an array. Okay, this is an array, and if we try to look at the shape of this, okay, we will see that there are almost 72413 rows. So this is giving my ball by ball statistics. Now if I try to print it also, what it was showing me, it was showing me some kind of a numpy array over here. This means in ball number 0 there was no dismissal, ball number 1 there was no dismissal, ball number 2 there was no dismissal, so on so on. In some ball with some match id, there were some 6 dismissals till now, there were some 7 dismissals till now, so like that. Okay, so this wickets is a data frame, and from that, and what I'm doing is I'm doing 10 minus wickets. So this will say me how many wickets are left. Basically here I have to write wickets left. Okay, so 10 minus wickets left. So if I do, so what this will do, 10 minus this 10 minus wickets means this 10 will be subtracted from the 0, so that means 10 minus 0 is 10, so 10 wickets are left for ball number 1. 10 minus 0 is 0. For ball number 2, 10 wickets are left still. For ball number 3, 10 minus 0, 10, ball number 3, 10 wickets are left. If I get till the last, that is 7, 10 minus 7, 3. That means for ball number XYZ in a particular match ABC, there are 3 wickets left till now. So that is what this wickets fallen meaning is. If I execute this, I can see over here 10 wickets are left because there were no player dismissed. There was no player dismissed, that's why 10 wickets are left. Okay, now you can see over here that in a particular yes, in the same way, okay, we can calculate it. Now we'll calculate the run rate. So what is the run rate? Run rate is basically the current score times 6, because there are 6 balls in a particular over, and in order to balance the balls, I'm subtracting the total balls, that is 120 minus the balls left. This means the same thing only. What does the run rate mean? The run rate is nothing but the current score divided by the balls, whatever the thing has been played. So that is what this is computed, and required run rate is also calculated in the same way. Instead of current score, we'll say the runs left. Okay, let's say the 200 runs was the target and my current score is 100, so runs left are how much? 100 runs are left. And how many balls are left? Let's say that score is 100 at 10 overs, so 60 balls are left. In 60 balls I need to score 100, so 100 times 6 is 600, 600 by 60, 100. 10 is the run rate. If I go with the pace of 10, I can complete it. Okay, so in that way. So this current run rate and required run rate is calculated. So once that current run rate and required run rate is calculated, we are almost there. Now there are few kind of computations which are required. So over here what we will see is we'll find out this result row. So this function is nothing but it will return 1 or 0. It will return 1 when the batting team is winner. Okay, else it will return 0. If the batting team is winner, it will return 1, else it will return 0. So delivery of result is equals to delivery df.apply result fun access is equals to 1. Okay, access is equals to 1 means we are doing column wise, we are functioning column wise, and then this result one function we are passing, and then as we are apply, this entire data frame will be passed. Okay, delivery.apply means not a particular column, not a particular group of columns, the entire data frame is passed. If I do something like specific columns like this, then that specific column is only applied to that result function. But if I don't pass anything, the entire data frame is passed to this result function, and in every row it is checking if batting team is equals to the winner team or not. If it is, then please say it was 1, else say it as 0. So let me just execute this. So it will take a little bit time because the entire data frame has been passed. So we can see that in the result 0 0 0. This 0 indicates what? The batting team didn't win, the bowling team won. Okay, the bowling team won, the batting team didn't win. So Sunrisers Hyderabad was the winner. That is why you can see that there is result is 0 because batting team didn't win, which was Royal Challengers Bangalore didn't win. Now if I try to look at the count plot of them, we see that there are almost like the more than 35,000 wins and almost 34,000 losses. Okay, so we got the result analysis as well. Now we will remove all the clutter which is not required. So we can see that there are 31 columns. We don't require those 31 columns. We require only specific columns like batting team, bowling team, city, the total number of runs left, balls left, wickets, total number of runs scored by the team in first innings, current run rate, required run rate, and then result. These all the columns are required and I have selected them. Now let me just press shift enter. I get all the rows. Okay, and this is what exactly I wanted. Now this is the entire pre-processed data frame. Now there are few categorical values which needs to get converted into numeric. That we will see in the model building phase. Till then, do explore the code of this and do practice the code. Alright, so in the last video we saw that we just took few records like current run rate, required run rate, wickets left. We calculated all those, and then we saw the count plot of the result, which is the one which we are looking for. Like this is a classification problem, and then we decided that we'll be selecting some rows like batting team, bowling team, city, runs left, balls left, everything, and then we will head forward for training and testing, right? So let's see the shape of it. We see that the shape is this, and then we'll see for the null values. We observe that there is some null value in the city. We will drop those because cities are obviously the locations which are there, only those locations are there, right? So we will drop it. It makes no use. You can simply drop it. And then over here, this step is very important because final balls left is not equals to 0. This should not be equals to 0. Why? Because you see over here we are dividing something with this thing, right? So if this term becomes 0, the entire thing becomes infinity, and infinity is like not applicable anywhere. Okay, so in order to overcome that, we are saying not equals to 0. Okay, so if we execute this, all the balls left except 0 balls left will be there with us. Then we will copy this final df thing into another variable named as data, and then we will separate the training and testing part. The column which we will be working on, or which we will be classifying or predicting on, is the result column, where the result column is either 0 or 1. It's a binary classification problem. And then we will say train is equals to train.drop result, access is equals to 1, train.head. If we do this, we'll get the training data set over here. Now we will split the training and testing data set. We will see the training columns. We will copy all this. We will import all these libraries and execute it. So from compose column transformer, which will take in the encoder which we want to. Like for example, if we want label encoder, one-hot encoder, or sparse encoder, some kind of encoders which are required to convert categorical variables to numeric variables. So we will import the one-hot encoder and two algorithms, random forest classifier and logistic regression. You can import as many classifiers as you want on your own. Then we will import this pipeline and then this metrics. So once this is done, now this is important over here. So as I said, this column transformer will take in this one-hot encoder or something which will transform the particular column. As you can see, the column name itself suggests column transformer. So transform a particular categorical variable column to a numeric variable column, right? That is what this means. So what encoder we are using? We are using one-hot encoder. So in one-hot encoder, what is the case is, what is the scenario is, suppose that we are having ABC. Okay, so wherever there is A, it will place it as 1, and rest all it will place it as 0. Wherever there is B, it will place it 1, and rest all it will place it as 0. And this drop is equals to first meaning is when there is C. Okay, when there is C, that means when there is 0 0 1, this defaultly automatically gives us the meaning over here. See, 0 0 1 0 1 0 means this represents B column. B is active, A and C are inactive. So we know that only A, B and C are there, no? So if A and B both are 0, that means C will be 1 only. So no need to consider this extra column. So that is the main intention of this one not encoder. Okay, so on what columns do we need to encode, on what columns do we need to give one not encoding? We need to give on batting team, bowling team and city, because those are all our categorical variables. So this is the column encoding, and then remainder is equals to pass through. So this is the column transformer object, and then we will create a pipeline. So this pipeline, I'll explain you what this pipeline is basically all about. So basically what happens is you are having data, right? So you are having data in form of, you will load the data from the databases, and then everything you will convert, everything you will make into one particular thing, so that every format is same. And now this data, what you will do is you will pass through a big pipeline here. So this pipeline is divided into several stages. So first stage is different, second stage is different, third stage is different, and so on. As tedious task, those many steps are involved. So in the first step, what you will do is you will convert all the categorical variables to numeric variables. Okay, first step is this conversion, categorical variables to numerical variables. Second step is transformations, like min-max scaling, or standard scaling, or some kind of scaling if you are using some linear models here, right? This is nothing but transformation. And over here you will use some feature selection, and after the feature selection is done, the fifth part will be model algorithm selection, or the algorithm selection. Okay, this will be algo selection. Using cross validation, you will select the algorithms. So these are the several stages after this. And after this also there will be some hyperparameter tuning, and also hyperparameter tuning, or many other steps will be there. So let's say that this is some algo, and then over here hyperparameter tuning phase will be there, and then the deployment phase will be there. So this entire thing is nothing but over here hyperparameter tuning is there. Okay, hyperparameter tuning. Over here deployment of the machine learning model, or deployment of the machine learning model as a pickle file. So this entire stage, whatever I said, is nothing but a pipeline. Okay, this entire stage which I just drew over here and which I just said is nothing but a pipeline. So this pipeline is nothing but, it will take in the list of tuples. Okay, as you can see, it will take the list of tuples. So this is it will take the list of tuples. As you can see, this is the list, and inside that list we are passing tuples. So it is nothing but a list of tuples it will take, and it will go in one the execution will go in one direction, like this, from left to right it will go. Okay, so data, we get the data, we will load the data into this pipeline. We will first convert the categorical variables into numerical variables using some encoding techniques. Over here we use the column transformer, so that is why step 1 is nothing but encode the categorical variables to numerical variables. Now this transformation and feature extraction is optional. You can do it, or you cannot. If you want to, you do it, otherwise leave it. So I just left it over here because I am having only 2 or 3 numerical two categorical variables, and not many, and almost everything is linear. So I'll just use some I just directly went to this model algorithm. You can use some transformation techniques if you want to. Step 2 is this logistic regression, which is the classifier. So this is our pipeline. So in this pipeline I will fit the data. CF is I didn't execute this one, so I executed it. Now I will execute this. So this is fitting. So my pipeline is created. So in this pipeline I'll send my X-test data, and then I'll calculate the accuracy score. So I see that 80% is my accuracy score. So I don't want the accuracy, I want the probability. Okay, because in the starting only we decided that we will calculate the probability, something like this. Kolkata Knight Riders is this much, Chennai Super Kings is this much. That means the losing team probability is this, winning team probability is this. Okay, we will find the probability. So in this probability, we get here array, or we'll get two indices over here. This will indicate 0 and this will indicate 1. 1 means winning, 0 means losing, right? So we can see from this count plot also, 0 means losing and 1 means winning. So that thing is done over here. 0 means winning, 0 means losing and 1 means winning. So this is nothing but the probability of losing. 54% chance that you will lose, 45% chance that you will win. So this algorithm over here I chose is logistic regression. You can choose another algorithm also if you want. You can choose random forest classifier as well. So instead of I'll keep everything same. Instead of logistic regression, I'm using random forest. So if I just try to predict the random forest thing, I'll see that the random forest thing will give me a good result over here. But I'll not consider the random forest because it gave me 0.999, almost 1 accuracy, 100% accuracy it is giving. But this random forest regressor, it is biased. In what basis it is biased? You just see there is only 0.06% of 0.06% chance for some team to lose and 0.94% chance to some team to win. This is exactly giving us the thing. But we don't want this. We don't want this kind of scenarios. We want that team A and team B must get some equal amount of chance to win. We want a model which predicts that kind of stuff. Okay. So over here in comparison with respect to probabilities, I find that logistic regression is good instead of random forest regressor. Logistic regression is good instead of random forest classifier, because random forest classifier, it is classifying till the extreme end. It is not stopping somewhere. Okay. So basically, if you look at the algorithm of logistic regression, how the algorithm will work is basically over here. The algorithm, how it will work, I'll just show you. I'll just give you the gems of what the algorithm is all about, logistic regression, how it will work and all that. So first, basically what will happen is you are having some kind of data sets, right? Some data is there over here, and you apply some kind of transformation to this data. Okay, some e to the x, there is some sigmoid function which you apply, e to the x by 1 plus e to the x. So the entire scale will go from minus infinity, the entire scale will go from 0 to infinity, will go from minus infinity to plus infinity. And then here you will plot some kind of here the data set is the data points are separated based on the classification and this thing. So basically there are two kinds of data sets, right? Two kinds of data points, right? Two kinds of classes, like positive class and negative class. So what will happen is positive class will whatever labels are there in positive classes, they will get occupied here, and whatever negative points are there, they will get occupied here. So here you can see that this is the thing, and then now it will try to plot a line over here, some y is equals to mx plus c line it will try to plot, and this y is equals to mx plus c line, this all data points will be reflected here. Okay, these all data points will be reflected on this line, and what will happen is we will find the reflection of this points like this on the x-axis, and then again once we find the reflection of them, of these data points on the x-axis, on this y-axis, we will again try to plot a sigmoidal curve, something like this. A sigmoidal curve will be plotted where over here this clutter will be of x and this clutter will be of y, and this will be the threshold. So this axis will be about probability. Okay, so what it will be of? It will be of probability. So when it comes about probability, in random forest there is nothing known as probability over there, even though the probability picture comes at the end. But in logistic regression, everything revolves around probability only. So for that's the reason I feel like logistic regression is giving a good result as compared to random forest classifier in terms of probabilities, not in terms of accuracy, but in terms of probabilities. So that is what I have written over here. Logistic regression is giving some good accuracy in terms of probabilities, not in terms of accuracy. Pardon it. Sorry for that. It gives a good result in terms of probability, not in terms of accuracy. So I will be saving the logistic regression model as pipe.pickle, and then I'll write the entire model in binary mode. So I'll execute this, and I can see that pipe.pkl, I have it over here, so I'll be using that model now. Okay, so that is all about the model building phase. A quick recap, if I want to do a quick recap on this. So the quick recap is basically about the pipeline only. We created a machine learning pipeline here. So what was the end goal and end motto of the thing is, we had the data which was pre-processed, and and all the features which we want were selected. So this was the data, and this data was passed into a pipeline, a big machine learning pipeline over here, which was created. So the first phase was conversion of cat to numerical variables, and then the second version was transformation, but we skipped it. Then we had the model selection. So we selected the model, and then this was the pipeline which we finally said that this pipeline we will be using into the deployment phase, and also we will be integrating this pipeline to the UI. So we are having this pipeline, we saved this pipeline. Now we save this pipeline in a pickle format. We save this pipeline in a pickle format, and now we will open this pickle format in UI. So the UI building course we'll see in the next video. Till then, do practice and look out for more algorithms where we can get better predicted probabilities than logistic regression as well. Okay, till then, do practice the code. Thank you. So in the last video we completed our model building phase, and we saved our logistic regression model, that is the logistic regression pipeline. And then we decided that we will be saving the pipeline in form of a pickle file, and then we will open that pickle file in the UI. So what is the advantage of pickle file is, pickle file is nothing but it will keep the structure of your model. Okay, it will maintain the same structure in which the entire workflow is there. It will not overlap the structure or anything, so you can easily store it. Okay, so let's see about the UI application. So here I will be using some Streamlit application. So if you have Streamlit, well and good. If you don't have Streamlit, just you need to just do pip install Streamlit, and the latest version of Streamlit will be installed. Okay, pip install Streamlit and press enter. I already have Streamlit, so it will show me requirement satisfied. If you don't have Streamlit, just install Streamlit using this command. So basically let's try and import all the dependencies first. So we'll be importing pandas, we'll be importing Streamlit, and we'll be importing pickle. Why we imported pickle, we'll see it later. We'll see in the coming part. Basically to unpickle this pipe.pickle our pipeline. Okay, so we'll declare all the teams which are part, that is Sunrisers, Mumbai Indians and all. Then we will declare the cities in a list. Then over here we are saying pipe is equals to pickle.load open. So first we will open the file in read binary mode, and then we will load it. That is nothing but pickle.load will load those weights or the training or no which the logistic regression pipeline was done on. Okay, then we will set the title as laptop price IPL win predictor. So once that is done, column 1 comma column 2 is equals to st.columns of 2. So there are two columns which I set it. That is nothing but select the batting team, select the bowling team. So I am selecting two columns. With column 1 I am saying that batting team is equals to st.select box, select the batting team, sorted teams. Nothing but this teams is there. No, I am sorting it with respect to their, I am sorting lexicographically. So basically what will happen is, if I see from Chennai Super Kings, it will get sorted from A to Z format. So C, D, K, 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 M, R, R, S. So batting team and bowling team are the same kind of teams only. I mean the list from which they are selected are same. So the same goes with the bowling team as well. With column 2 bowling teams, st.select teams, sorted teams. Now for city, st.select box city. So I am having some few cities like Abu Dhabi, Ahmedabad, Bangalore. This is also in sorted order. All the venues of IPL, wherever the IPL matches are held, all those cities are considered. Then I am considering the target. So what is the target which has been given by the opposition or which the team just batted? Okay, the target, that is a number input. And then column 3, column 4 and column 5, st dot columns 3 column, this is nothing but column 3, this is nothing but column 1, this is nothing but column column 1, column 2 and column 3. Okay, that is nothing but st dot columns of 3. Now with call 3 I am saying st dot number input score, that is nothing but score over here. So please enter the current score. Basically it should be current score. You can change it, you can say current score, instead of score you can say current score. Okay, then overs completed till now, basically. Okay, overs completed till now, and then wickets fallen till now, and then the wickets fallen till now. So wickets fallen till now. Now with st dot button predict probability, whenever the user will click on this predict probability, the entire working of the algorithm will start. So first we will calculate the runs left. So runs left is nothing but the target minus the current score. Okay, and then the balls left is nothing but 120 minus overs. As I in the previous video, as I said that overs will be giving in some kind of ones and zeros only. Overs completed, right? 1 0 1 0. So maximum if the over is 10, so that means 10 into 6 is balls will be 10 into 6 60, right? So 120 minus 60 is 60 balls will be left. So let's say that some 10 overs are completed. So how many balls will be left? In 1 over 6 balls are there. So 10 into 6 is 60. 120 minus 60 is what? 60 balls are left. So that is the balls left. And wickets is nothing but the number of wickets which are left. So for example over here I said that 7 wickets are fallen. So how many wickets will be left? Wickets left is nothing but 10 minus 7, that is 3. 3 wickets are left. So I'm having runs left, I'm having balls left, I'm having wickets. Then current run rate is what? Scores by overs. Simple. Required run rate is what? Runs multiplied by 6, because there are 6 balls in 1 over, divided by balls left. As simple as that. Now over here you just you have to be little bit careful over here. As we are using the pipeline architecture, we are passing in the data frame as an object. We are passing in the data frame as a data source to our pipeline. So we have to make sure that our batting team is in form of a list of input, bowling team is in a list of input, city and everything is also in list of input. So everything will be passing in list of input. Once we create our data frame, that is nothing but the input data frame, we will pass this data frame into the pipeline. So first what will happen in the pipeline? In the pipeline it will, the categorical values will be converted into numerical values. As I said, the categorical values will be this data frame is been passed. So first categorical variables are converted into numerical variables, and then categorical variables will be converted into numerical variables, and then the model selection is done. Okay, which is nothing but the logistic regression, and which will predict the probability for us. So loss probability will be for where, so we'll get this, right? So if you want to get this thing, so this is nothing but the loss probability. Okay, this is nothing but the loss probability or the zero class. So if you want to get that, it is present in 0 0 index, and if you want to get the win probability, it is present in 0 1 index. So once we get the losing probability and winning probability, we'll say batting team plus this str round win prob star 100 plus this, bowling team plus star round loss prob star this. Okay, so winning probability will be in decimals, no, so we need to convert it into rounded figures. So we'll multiply it by 100, and similarly it will go for losing probability also. Okay, so batting team will have winning probability, bowling team will have losing probability. Okay, so why we will have this winning probability for batting team only, why not for bowling team? That is because what we considered over here, if you see over here, our classification thing is, we said that batting team must be equals to winner. We considered our classification, we made this result column based on the batting team status, not on the bowling team status, because the bowling team because we are predicting for the second innings, not for the first innings. So in the first innings already one team has batted, right? So we'll be considering for that. We'll be checking, or basically this entire thing is based on the second innings model. So in second innings, the first innings team will bowl and the second innings team will bat. Basically there are two teams now. In the first innings, the one team will bat and the other team will bowl. in the second innings the other team will chase the runs which the first team has batted and scored. So on that kind of model this entire thing is made. So we will be writing the batting team result and the bowling team result in form of probabilities, and the result will be something like this. If I just execute this, I get it will rerun, and again I'll get the same kind of result. If I increase let's say that I increase it to 8, okay, and if I hit on predict probability, I see that Chennai Super Kings can win 88% because Chennai Super Kings batted first, and Kolkata Knight Riders at the end of 10 overs they have lost 8 wickets. So there is the probability of Chennai Super Kings to win is 88% now, and Kolkata Knight Riders have only hope of 12%. Why they are having this much hope? You can say that they must have only 1% hope. No, so we can't say anything in cricket. Basically some tailenders will come, and if they batted very good, or who knows that some kind of striker batsman is still there who came in one down and he is still there at some score of 50 or so, he can also dominate. So for that's the reason why I didn't choose random forest. If I had chosen random forest, this would have given me some 4% for Kolkata Knight Riders and 96% for Chennai Super Kings. That is right in terms of data. But when you're deploying this model in terms of public, you have to make sure that the losing team also gets some kind of weightage, because you don't know what miracle can happen after this. So for that's the reason we have to be a little bit smart in selecting our model algorithms. And to explore more on this, and in the next video we'll see the deployment of this on Heroku Cloud. Hi. So in the last video we look at the integrating our pipeline with the UI which we made using Streamlit. Now we will look at the deployment of this machine learning model which is on Heroku Cloud. So let's first see how to get through Heroku. So if you are new to Heroku, then you can just hit on sign up. Okay, so you can fill in the details over here, and then there will be a particular email address verification link which will be sent to the email address which you give over here. So you just hit on verify, and then your email address will be verified, and then your Heroku account will be activated. Once your Heroku account is activated, you just fill in the login details and activate and hit enter. So you will be allowed to enter the Heroku Cloud service. So after that you will have an interface something like this. So over here what we need to do is we have to create our apps. So basically make sure that over here when you're selecting the language you select Python, because we are coding everything in Python. You do not select any other language. You make sure that you select this Python thing only, otherwise there will be a problem. So next what we will do is we will create a new app, and then we'll give some name to this. Let's say that IPL, it's not available, IPL score prediction, IPL score prediction, second innings. If you give some big kind of names, it will come innings. Okay, just ignore the spelling for now. Okay, and also you can see that the title length should be less than some characters, because I'm pressing N and it is not taking. Okay, so everything must be carefully chosen. The title you must choose carefully. Once you choose this title, then you simply hit on create app. Okay, once you hit on create app, now here you will be having some three options through which you can deploy this app on Heroku. One is using the command line interface of Heroku, one is using the connect to GitHub, and one is using this container registry. So as I'm using the Streamlit application, I'll be using the command line interface over here. So basically when I'm using the command line, first in order to check whether you have the command line interface installed or not, for that what you do is first you write in Heroku. So if you write in Heroku, if this kind of message appears, that means the command line interface is there already installed on your system of Heroku. If it is not installed, then kindly go to this link and install the command line interface as per your system requirements. So for if you are having a 32-bit Windows system, then install this installer. If you are having 64-bit, you install this. If you are a Ubuntu, if you are a Linux user, then install this. Okay, so in this way you can install the the command line interface. Why I am using command line interface over here is because of this Streamlit app. So in Streamlit app there are three files which we have to include. One is the proc file, one is the requirements file, and one is the setup file. Requirements file and proc file will, if you are deploying on Heroku, then requirements file and proc file is must and sure. But the setup.sh file is nothing but the shell file or the script file which says the Heroku server that hey, this is the file from which you have to set up everything. You have to set up the Streamlit environment for our application, because we are using the Streamlit app. Okay, so that is what is being said. -b Streamlit, you create a directory like that, and then this is some server code which has to be written, which has to be encountered in that server production of Heroku. And then this is the Streamlit config.2ml. This file is majorly responsible for initiating the process. So once this setup file is executed successfully by Heroku service, then Heroku service will go to the proc file, and then it will first see that it is a web-based application. Then it will see the setup.sh file and Streamlit run app.py. So first setup.sh as it has got executed, then it will go and execute this. So before that, what will happen is, first it will see the requirements, it will install all the dependencies. Once all the dependencies are installed, it will run this command. Okay, so this is about the internal working of Heroku service, how Heroku service is working. So now what we have to do, step by step, we have to copy this code and paste it into our terminal. So don't copy the first code, that is cd my project, because that is, you are already in a folder. So don't copy that, you just paste it, you do this. So an empty git repository is initialized. As you can see over here, the master symbol has come, that means a git repository has created. Okay, then you copy this Heroku get remote and everything, git remote, and then paste it over here and then hit enter. Simply you have to just copy and paste, that's it, nothing else. Then you just do this git add star. Once you do this git add star, you paste it, git add star, and then hit enter. So it will copy and paste it. Then use git commit, and then just hit enter. So it will commit all these files whichever are there in this. Then what you need to do is simple, you need to just push your project into Heroku service. Now git push Heroku master. So if you just hit enter, this will push all your Heroku services. This will push all this code, that is from gitignore to setup.h on the Heroku cloud service. So first what Heroku will do, Heroku will go and see the proc file, it will see setup.sh file, it will go to setup.sh file, it will make this folders and make this initializations. Once everything is made, it will go back to proc file and it will start with this. Okay, so over here it is saying that the push has failed, master. Okay, it is showing some kind of error over here, download couldn't satisfy a version of pickle. Oh, okay, so you must be very careful when you're selecting this things also. Okay, there is no requirement of pickle in this basically. So your requirements.txt file must be changed accordingly. Now what you need to do is, you need to delete this app, because this app got the push of this app was failed. So because of the error which I faced over here, what I need to do, when you face this kind of errors, first thing what you need to do is, you need to delete the app. Okay, you delete this app here. Okay, you delete this app here, and then delete the app. Okay, once you delete the app, you again start the process again. Okay, so now again you create new app, you hit there, and you hit your IPL second innings, you hit your IPL second innings score, sorry for the typo, score predictor some name you give, it should just get activated. Okay, it should just get accepted. Then hit create app. Once you hit create app, now what you need to do is you need to be very careful. Now in this requirements.txt you have to install only those dependencies which needs to be installed. Okay, pickle file is not to be installed. I just randomly wrote it in here and I got a very big error over here, so we have to be careful in this. Okay, we require pandas, sklearn and streamlit. Now what you do is, now first you write in Heroku. First you write Heroku here. Okay, you write Heroku, you see that Heroku CLI is installed. Then you write Heroku login. Okay, just in case you need to log in to Heroku, then press L. So you will be redirected to some kind of interface like this, where it will tell you to log in. You just hit login. You're successfully logged in as so and so email ID. It will come. Then what you need to do is you need to start with this process again. Okay, no need to use the cd my project as I said earlier. Just initialize this. Okay, reinitialized existing git repository, no problem at all. Just simply copy this code and then paste it here. Okay, once you paste it, now do git add. Okay, do git add. Once you do this git add, it will add all those repositories. Now do git commit, make it better. Do this, paste it. There was one insertion and 2 deletion which was made in this requirements.txt file. Only we did some insertions and deletions. That is why one file changed. So you can see that it is dynamically getting updated. And then just copy this and then paste it here and then hit enter. Hopefully it should deploy now, because we had used this, we had changed this dynamically, right? Let's see what the result it says. You have to be little bit careful in this kind of situations. This kind of situations occur directly on it. So as you can see that there is no requirement which has been errored here. So everything is getting perfectly installed. Now let's wait for 1 minute or so that the entire deployment takes place. So yeah, I think so there will be no error in this. Just 2 minutes, just 2 seconds, there's like 20-30 seconds, and then the repository will be hosted on Heroku. So you have to make sure that everything is perfectly fine and perfectly written. See, existing git repository, you can also add this kind of code in if you have just changed some kind of things. Okay, but if you have not changed anything, yeah, now it is compressing. So just few times it will say. So you have to be very careful while you're writing this requirements.txt file, because this is the main thing. If you just make any error in this, the push will be failed. So first it will go, first the Heroku service will go to the proc file. It will check everything what is there. Once that is done, it will check the requirements file, which is to be required, which all dependencies are to be installed. So it will install it. After that installation is done, it will execute the setup file and then the app file. So requirements.txt is the key or the main aim of Heroku file over here. So this has been released. This app has been deployed to Heroku. It is shown that deployed to Heroku. It is just pushing some files. Once that is done, we will look at it. Okay, so just 2 seconds or so, it will take some time and then it will push it. So as you can see that all those repositories, all those dependencies, it automatically installs, because this is a Python app. Yes, so we can see that the deployment is successfully done. There was no error now. The only error in the previous thing was I included pickle. That should not be included. I removed it and I saw that the application got deployed on Heroku. Let's see how the application is looking like. So over here, if I see the application, it is loading, and like this you can change the this thing also. You can use the system setting to be dark, and then you can apply it on dark mode. Let's say that the team is Kings 11 Punjab batting team, and it is Chennai, and target, let's say it is 200 and let's say target is 180 runs. Score, currently the score of Punjab is 120, and 15 overs are completed, and 6 wickets are fallen down. Now let's see, this is kind of a tight situation. What happens? Yeah, so Kings 11 Punjab has 5% chance to win, and Chennai Super Kings has 95% chance to win. How come this is possible? 5 overs, that means 30 balls. 30 balls, 60 runs, 6 wickets already fallen. So there is less chance. Let's say that if the number of wickets fallen were, let's say that 2 wickets were fallen, then the chance would be more. See, 42% chance is more, because when it is 2%, that means when 2 wickets are fallen, that means currently 1 down and 2 down batsmen are batting. That means the main batsmen of the team are batting, so that is why the prediction is high. But let's say that if they were like 8 wickets had fallen down, then the chance is almost negligible. Okay, so in that way this is working perfectly fine, and I hope you enjoyed building this app. Do explore more on this, and instead of using logistic regression, if any other linear model was possible, you can also use that as well. I hope you enjoyed this video and you enjoyed this small project of IPL win predictor. Till then, do explore on this, and take care. Thank you.